Hello and welcome to the 7th video that I'll be posting in my Unity platformer series, and today we will be discussing about coding, the player movement, and create scripts in Unity. So what I like to do when I create scripts in Unity is create a folder so that they're all organized, and to do so I can simply create a folder in our assets called scripts, and inside of scripts I'm going to create a C# script. So I'm going to right click, create C# script, and I'm going to call this player controller because we want to control our player, and this script will do that. So what I'm going to do is I'm going to go to player and I'm going to drag player controller to the player inspector so that we can get the script connected to the player. And now I'm gonna double click on the player controller so that we can go to the Visual Studio Code. Now in Visual Studio Unity, it's gonna be a little bit different from what we've expected from yesterday. And the main difference is that, first of all, we're not using system and we're using system.collections and a lot of other Unity engines. And then we got public class player controller dot mono behavior. That is just how Unity system works, and we don't need to change anything about that. And what you directly see is void start and void update. So void start is the function. Let's just say in Unity, void is a function or protocol that we can call, and void start is the protocol where Unity, when we play the game or when we start creating the game, it will directly initialize and call out the functions. And then in void update, it's where all of our code will be gone through and it will be affected in every frame. So every frame it's going to call this function, make sure everything is fine. Then every frame is going to call out every function. So it's basically the thing that can be allowed to be moved in every frame. And then we got void start and void update, okay? And both of these voids are created directly by Unity and you don't need to type anything inside of them. Okay, and another term I've got to teach you guys is the two types of inspector variables. So in Unity, we have these public inspector variables and private inspector variables, okay? There's two types, public and private. So I'm going to teach you guys the difference between them and when to use them. And the use of inspector variable is, from its name, inspector, is variables that are usually assigned based on this. As you remember from the previous video, I've mentioned that rigid body is the type of is the component inside a player where it gives forces towards the player, right? So what we're gonna do with the movement is also similar to that. We're gonna assign the player rigid body to push in the left direction or the right direction for the player to move. And to do so, we need to connect the scripts with the inspector variables. And to do that, we have to use either the public or private inspector variables. So I'm going to teach you guys the two different types of inspector variables, and that's public and private. And you can see that these variables here is actually used only for inspector components like this. It's like rigid body 2D. You can also use box collider, for example. Or you can use a composite collider, for example. There's a lot. As long as all of these are inspector, we can use public and private, and also other like int variables, string variables, and many more. So public rigid body 2D. The funny thing about this type of variables is that instead of giving it a value, we type in public rigid body 2D, which is the inspector or type here, rigid body 2D, and then we put in the name here, the name. So we're gonna call it player RB2, and don't forget the semicolon, and then we're gonna go to rigid body 2D and type in player RB and semicolon. So as you can see, the main difference between them is actually when we go back to Unity here, we can see that player RB2 is seen in the inspector, meanwhile player RB1 is not. And this is caused because of private and public. For example, let's just change the private here to public to give you guys a more understanding. And then as you can see, if we go back here, the player RB now can be seen. And the main reason why we want to use public and private is because private will directly increase security and public does not. Public is just allowing people to see directly in this. However, the advantages of public is that we can easily edit these variables. However, to finalize the game, I usually like to use private. Let's just use private because we don't need to take any other inspector variables. We don't need to take any other inspector variables from outside the player. And we can directly increase the, like I said before, increase the security level of this variable. And then we go to private rigid body 2D player RB. However, we've made a variable. However, we haven't initialized the variable, and there's nothing to tell that this is the player RB, and player RB is this rigid body. So we can do that in void start. As you can see from the definition Unity gave us, start is called before the first frame update, which means that this is the type of function that can be used to initialize all of our variables. So player RB, we know that player RB is a type of rigid body, but we don't assign which rigid body player RB is assigned to. And we can do that in void start. We can do that by typing in this code, which is self-explanatory actually. Player RB, okay, we type in the name, of course. We've got to type in the name. And then we're going to say equals to what we want. We want it to get component. And then as you can see here, if we follow in the Visual Studio code here, it says T. And T means this, the inspector variable. And that's our rigid body 2D. We've got to end this with a bracket and semicolon at the end, because that's the C# rule to always end with the semicolon. Okay, and now we can know that player RB actually gets the component rigid body 2D. And when we say this, it means to get the component from itself. Okay, to get component from itself. And if you want, for example, take other components from, let's just say, enemy or another sprite, and we want to take that rigid body, we have to use a public, because public can also do this. However, let me show you the difference. It requires us to Control S. Make sure that you always Control S so that the green marks here show it. That we have to, it says non-rigid body, and we have to drag our rigid body from here to the bottom like this. So this might be beneficial because let's just say we want to take rigid body from the enemy, another enemy here or something, and there's a rigid body, we just want to drag it to the player. We can actually do that by using the public. However, like I said before, it reduces security and chances of exploiting bugs and stuff like that. So I don't really recommend using it. But if you already know, like, you just want to take the component inside the player, you can just directly type in this code here instead of allowing it to show in the inspector. Okay, and we're going to use a lot of this code here: get component, stuff, bracket, and semicolon. And now we're going to create another function for our player so they can move. And in Unity, every function is called starts with the word void, then something, and then brackets, and then the function. So this is how we're going to type in our function. So we're going to create a new function by typing void, the name, which is going to be player movement, because I want it to move the player. And then, as you can see, there's this bracket here. You click enter, create the paragraph with the curly brackets, enter again, and now we can type in our code. Okay, to type in the code, we can use if statements from the previous video. And just create if, then we want to make a bracket, and we're going to put in our condition. And the condition is, if let's just say the player touches the key A, it goes to the left. And to do that, we can just say, what do we do when a player presses a key? It's input, right? It's input, and then what? We get what? they press a key. So we input, we get the key. Okay, we get the key, and then if we follow Unity just now, when we type in input, I'll get key here, get key. It says here key code. It says bracket and then key code key. So what I'm gonna do is just gonna follow the Unity follow the Visual Studio guide and just type in get key brackets and it says key code key. And it directly assumes that I'm gonna type in key code, so I'm gonna enter key code, and then it says key. It's gonna click in dot, and then we can choose which key we want, and the key we want is A. Okay, and then like I said before in the previous video, when we create an if statement, we gotta make paragraphs again, right? So we're gonna click enter and create the paragraph, and this will be the function that's gonna be, the code that's gonna be executed when the if statement is true. And what we want to do is we're gonna add force to our player. And before I just said player RB controls all the forces, right? So we're gonna make sure that the player RB, which is assigned to be the player's rigid body, which is this player RB, and we want to add force, right? We add force brackets, and it says, oh, there's two options. You can either go to vector2 force or vector2 force mode 2D. And I'm going to take the second one because it is more complex and more detailed. So vector2 force, I'm going to type in vector2. Now what's the force? We want A to be left, right? So just type in left, comma, force mode. Force mode 2D, and then it says mode. So I'm just going to type in dot. There's two types of force, mode 2D, force or impulse. And as you can see, my Visual Studio already provides me with information. And force is add a force to the rigid body 2D using its mass. And impulse is add an instant force. So when we want the player to click on the keys, we want it to be as responsive as possible. So we're gonna use the impulse force mode. Okay, and as you know, C# rules, we go with end with a semicolon. Control S, so that yellow bar is now saved. And let's just try to move our character. As you can see, when I click A, it does not move. Well, the main reason why it does not move is because I only set vector2 left. I gave a direction for it to push, but there is no value that can increasingly exponentially push the character because of its mass. So what we're gonna do is we're gonna create another variable, and it's gonna be a public variable because I want to teach you guys why we're gonna use public sometimes. And I'm gonna make it a public, let's just say movement speed, because we're gonna multiply it by the vector2 left so that it can give more force. And public, it says, oh, I forgot to put an int here so that it can identify that this is an integer. And as you know, end with a semicolon. And now when we go back to Unity, Unity directly gives us our movement speed, 0. So what we're gonna do is we're gonna type in our value, which is 20 probably. And then we don't need to initialize it anymore because Unity already initialized the value here in Unity. And we're just gonna go to vector2 left and directly multiply this by our movement speed. By doing that, we should have access to the player's movement. However, as you can see, when I click, it does not even allow me to move at all. Well, another reason why it does not move is because, as you remember, this is our own function. And our function does not call every once per frame. Only the void update does. That means we have to call our function in the void update. And by doing that, we type in player, player movement, which is our function name, and add brackets. And these brackets is usually inserted parameters. But you don't need to understand parameters now because I'll be discussing that in future videos. and always end with a semicolon. And now we should theoretically move. Boom. You can see we lost a player. So let me just another feature I want to tell you is if you're lost somewhere here and you wanna relocate your player or your sprite, you can double click and directly you'll get teleported to them. I'm gonna move this through here so we can see the movement clearly. And if we click A, boom. Wow, that was super fast. But I found a bug in this, and that's it says update is called once per frame, right? And if you were talking about a high-speed laptop, which calls out 60 frames per second, for example, then it's gonna move fast. And let's just say an old laptop that can only hold 10 frames per second, and it's gonna move slow because it's part of a factor in the movement, right? And it's not gonna be fair because sometimes you can jump high, sometimes you can jump low. And what we need to do to make them fair or consistent movement is to multiply it by time dot delta time. So what I'm telling you here, the time dot delta time here is actually a code that allows us to, as you can see, there's our definition here, the completion time in seconds since the last frame. So that means that when a computer loads 60 frames per second, update will be done 60 times. However, with time to delta time, there's going to be like one frame, one check, player movement, then 1 second, player movement, 1 second, player movement, 1 second, player movement. So it won't actually be able to have random speeds depending on how strong your laptop is, or computer. It will be consistent because of this, the completion time in seconds since the last frame. So I want you guys to remember this code here because I do not have any other shorter ways to explain this because this is directly a code that Unity provides. So you got to remember that time, that delta time is a factor. It can help you make constant frame updates. Okay. So now I want you guys to see that when I did multiply time to delta time, now you can, as you can see, the movement isn't as fast as now. It's consistent, whereas before it's just stronger laptop, faster speed. Okay. Now if we go back to player movement here, and we're gonna go to our 29. I want you guys to do this as part of a challenge. So I want you guys to make another movement for another code for the movement here, for the player movement, and that's for key code D, and the player movement will be going to the right. So I want you guys to make another code for player movement so that when the player clicks D, the sprite or our player will move right. So pause the video right now and do the challenge. Okay? So for those of you who have succeeded typing in the code, very nice. But for those of you who haven't and cannot do it, it's no problem because this might be pretty challenging and confusing at first. So what we're gonna do is I'm gonna review all the code that we've done just now, and what this basically means is we're gonna type in if input get key code dot d, okay, because we want to make sure that the player input, so the player's input when touching the key D will cause our condition, which is player RB, because rigid body deals with all the forces. I'm gonna add force. Okay, I'm gonna make sure that the vector 2, you can see I'm gonna do number 2 because it's more specific with force mode. Vector 2 force, which is right, because we want to move it right? And there's also up and down, which will be used for later videos. And then multiply it by movement speed because we want to make sure that it's not that slow and the movement speed actually affects the speed. And I'm gonna multiply by time dot delta time to make sure that there will be consistent speeds. And finally, force mode 2t is gonna be impulse. So if you did force mode 2d dot force, then it won't be as instant as impulse. And yeah, and the main reason why you might be asking, or you might be wondering, why I did not use else if here. Well, the main reason why I did not want to put an else if here is because if I made an if and an if, that means both of these conditions are run at the same time, and if any of them are correct at the same time, they can directly be affected. However, if I use else if, then it must have checked the if first. The computer will have to check if this is correct. That if this is not done, then this is done. There's like 1 second delay or just delay, not 1 second, just depending on how fast your computer is, or laptop. And if this code is not executed, then you have to check for this, and if this is not executed, then this again. But then that would mean that they are not run at consecutive times, where if I just use another if, at any time, at any moment, there will be no delay. Because, for example, let's just say, I just want to move like this here. I'm going to test the movement. We just want to move fast like this, right? But then if, for example, we use else if, then it's going to make sure that this is checked first, then this, and this again, and this is like that. And there will be a delay. So that's why I use double ifs, which means that they will run at the same time, and at any moment, if any of these code or conditions, if any of these if conditions are true, then it will directly execute. And let's just see. Okay, to review all of this, I want you guys to remember the new type of writing inspector variables. And I want you guys to remember also the code here, and that's time.delta time. Okay? Because time.delta time is a pretty self-explanatory code that you just gotta remember because that's how it is. So yes. Okay, so now if we actually play the game, we can see that the player is actually moving. And even though it's fallen down, gravity is still affecting on it, as you can see. However, the main problem with the game right now is that when we move to the left, the player does not see left. The player is still looking at the right, so it's basically like moving backwards. And we don't want that. We want the player to actually see the left, and there's no walking animations, and sometimes the player can even fall down due to excessive force. As you can see, the person is tilted and can't get back up. Well, in real life, we don't want this, so I'll be solving this in the next video. So I guess that's it for me today. I hope you guys enjoyed this video. I hope you guys learned a lot about Unity programming, and I'll see you in the next video.